Okay, so I think we can start now. Good evening, offline, like online. Can you please confirm me whether I'm audible or not? Okay, so we can start now. So in today's class, we are going to discuss about the concept called volumes in Kubernetes. What we're going to discuss? Already, you know volumes in Docker, right? But in Kubernetes also, we are going to use the volumes. That is what we can call as PV and PVC. Which one? Have you ever heard about PV and PVC? Be that nice, Une. One of the interesting topic in the Kubernetes itself. I'll tell you like how to do it. But before that, let me create the Minikube mission and I'll explain the concept for you. Minikube. Yesterday, example. I'll tell you later. Don't worry. Okay. Ubuntu T2 medium. What is the volume you want? 20 GB. Today is date of Kubernetes, right? I think we begin in the Mondays. Sorry, Mondays, not Saturday. Last week, not before that Saturday, we begin. Before Friday, na? Okay. That means 1 plus 6, 7 is the 8th class. Okay. Still, it will take some classes. So after PV and PVC, which topic is pending? I need to check. Ah, okay. Machine learning. So in that entire workshop, Docker, Kubernetes, Terraform, three covered. Basically, to explain the Kubernetes architecture, it will take one entire class. Even though in the day one, I just given a brief, but we need to learn a lot of things that I'm going to tell like slowly one by one, one by one. Sudo hyphen I vim minikube dot sh. If I go to my minikube Ubuntu, I'll copy the script and I'll run it here. Okay. So let's go and understand what is PV and what is PVC with the help of a small diagram. Okay. Basically, the meaning of PV is nothing but persistent. What is the meaning of PV? That means always available. That means always available. PVs are independent, that they can still exist if nobody is using them. That means, see, persistence means always available. Volume means which can store the data. That means if I have the data that is always available for my pod, that is what I can call as my persistence volume. These persistence volumes are completely independent. That means, for example, if I create a pod, and for this pod I attach the volume, what I attached here, that means my pod will be there and volume will be there. For example, if pod is not using my volume, still my volume will be there. It doesn't matter whether pod is using my volume or not. My volume will remain same if no pod is using them. And whenever a cluster administrator created a cluster, after creating the cluster, he need to create the volume. That means creating the volumes will be responsible of a cluster administrator. But creating the volume can be done in two ways. Okay, after creating the cluster, you can create the volume, or after creating the pods also, you can create the volume and you can attach to them. So I think all of you know how to attach the, what do we call this one? How to attach the volume to the existing content already we seen, right? Here also already existing volume we can attach to the pod itself. Once PV is created, then it can bound to something called as PVC. Here PVC is nothing but persistence volume climb. Let me go for the diagram here. See, once I create a cluster, it is my cluster. Okay, I'm making it very big here. It is my Kubernetes cluster. In this cluster, for the volume, I'm going to create a PV. What I'm going to create? PV is nothing but total number of volume available for my cluster. I am writing it here very, very carefully. PV is nothing but total volume available for what? Cluster. In the diagram only, I'm giving the notes for your better understanding. So let me make it. PV is nothing but total volume available for the cluster. And who will create it? Admin will create it. Who will create it? Admin will create it. Fine. So now after that, what happened? Once I create the volume, this volume that I can distribute to the any of the running pods. For example, see, these are my pods actually. These are my mini pods where I can run my application. Okay. It is my pod 1. It is my pod 2. And it will be my pod 3. For example, let's create 4 different pods. I have 4 different pods. Now I want to distribute the volume to the 4 different pods like this. So PV for pod 1, PV for pod 2, PV for pod 3, and PV for pod 4. Now these 4 volumes can be able to use my data. That means whatever you put the data on PV, the data will be shared to the 4 pods. But practically, it is not going to happen in the real time. Why? Because PV's main purpose is to create the volume, but it cannot distribute the volume to the pods. Why? Because if you want to distribute the volume for the pods, PVC will distribute the volume to the pods. Which will distribute the volumes to the pod? PVC. There is a special component called PVC inside our cluster. This PVC responsibility is to distribute the pod. See, once PV is created, it can bound to the PVC, which is request for pod to the storage. For example, if this pod wants 2 GB of storage, this pod will go and ask for the PVC. This pod is going to ask for the. Now this PVC will go to the PV and take the 2 GB and give to the pod itself. This is how the things will work. For example, in the practical way, let's consider I have 20 GB of volume. How much? 20 GB of volume for my PV. Okay. Now pod 1 request how much of volume? How much? 2 GB. So this pod 1 request only 2 GB. So this 2 GB is going to be requested by PVC. Who will request the volume here? So PVC, what is PVC here? Purchase volume claim. Take volume from PV, and give to and distribute to pods. Wait, let me increase some font size. It is 18. My main intention is to make this concept very clear for all of you through the diagram itself. No need to no need to go and refer the notes. And distribute to the pods. Okay. So it is going to work like this. First of all, this pod will be going and asking PVC, I want 2 GB of volume. Now PVC will go and ask for the PVC. In the 20 GB, okay, in the 20 GB, PVC will give 2 GB of volume for the PVC and it is going to give it to the, pod. See, first of all, this PVC is having 20 GB. This PV can take 10 GB. For example, let's take this PV can go and take the 10 GB. Now PV is having 10 GB of volume. In this 10 GB, it is going to give 2 GB for the pod. Now again, second pod will go and ask for the PVC. It is going to ask, I want some data. Now again, this PVC taken data from PV. Out of 20 GB, PVC taken how much of GB? Now in this 10 GB, this pod is asking 3 GB. Can it give 3 GB now? Even though if it gives 3 GB, now total, how much of GB I'm having now? You need to check with the PVC. Now PVC having how much of GB? 5 GB. Again, pod 3 is asking 5 GB now. How much? So pod will go and take from the PVC itself. Pod will go and take from the. Now out of 10 GB, PVC has given 2 GB for pod 1, 3 for pod 2, 5 for pod 3. Now out of this 10 GB, it is completely distributing the data for pods or not, sir? Now whenever the fourth pod will be going and ask for the volume. Now PVC is having volume. No, this PVC can again take volume from the PV itself. That means if pod want the volume, pod will go and ask only PVC. If PVC will have the volume, it can distribute. But if PVC is not having the volume, PVC will go and ask for the PV. Is it clear for all of you? Again, similar Docker architecture example. These pods are nothing but child. Child wants some money. Child will go and ask to the mom. If mom has the money, mom will give the money. But if mom is not having the money, mom is going to ask for the similar example or not, sir? Here also, first of all, PV will maintain the total volume for the cluster. But PV cannot distribute the volume to the cluster. That is the reason we create PVC. Now, PVC will take volume from the PV and it can distribute to the pods. Okay. For example, if PVC is not having sufficient data again, PVC is going to ask for the PV. Okay, sir. It was fine. Now here my question is, for example, PV is having total how much of GB? But PV given the volume 10 GB for PVC. Now still PV is having how much of GB? 10 GB. Let's understand. PV is having now how much of GB? Now here my question is, sir, for example, PV is having only 10 GB. How much of GB? But this time PVC is asking 100 GB. Is PV having 100 GB? Now in that case, what will happen? In that case, two things will happen. Either PVC will remain unbound. Unbound means it is not going to get the volume. Second one, whenever a PVC is unbound, Kubernetes will create one volume automatically itself. That is what the point mentioned here. Okay. If you can go and see, if it is not suitable, PV is found, Kubernetes will either dynamically create a new one or PVC will remain the unbound. That means if my PVC is wanting 100 GB, but my PV is having 10 GB, two things will happen. Either my Kubernetes will create a PV with 100 GB or this PVC will not take unbound like that. Here, what are the points I mentioned? You can see it here. When a pod requests a storage via PVC, Kubernetes will search for the PV. If PV is bound to the PVC, then pod can use the storage. But unfortunately, if PVC required 100 GB, but PV is having only 10 GB, either Kubernetes will create a new PV with 100 GB or it is going to remain unbound. Is the logic clear for all of you? Uh, One more. We will. I'll tell you how to do it, okay? So, this is the concept of PV. Now, before I go and explain PVC, is PV clear for all of you? Online, can you please confirm me what is the meaning of PV? Can you please confirm me once? And one more thing, I put it online. Online, are you able to hear me? Is the concept clear for all of you? Good. So everything, the concept is remaining from this diagram only. If you understand the diagram, the concept will be very easy for you to understand. Clear. Then what is PVC? Already we defined, okay? To use PV, we need to claim the volume by using PVC. PVC can request a PV with your desired specification. That means you can specify the size of the PVC, that means storage, how to access, mode of access, and speed of data transferring from the Kubernetes. After bounding is done to a pod, you can mount it as a, that means, for example, if this pod wants 2 GB, if it asks PVC, PVC is having 2 GB. Now automatically this PVC will attach to the pod. Now pod will use this PVC as a volume itself. That means mounting. What do we call as? Once user done with the work, whatever the PV and PVC he is attaching for the pod, he can release that one. That means in future, if some other pod want to use the same data, he can reuse it. So this is the concept of PVC. Simply, I'll tell you one thing. There is a concept called stateful and stateless. Stateful and what is the meaning of stateless? Stateless means your previous data will not be stored. Your previous data will not be stateless. Stateful means your previous data will. For example, I have a pod. What I have? In this pod, I log in for the very first time. I intentionally created some files. What I created? Files. After creating the files, unfortunately or fortunately, I removed this pod. I deleted this pod completely. Now what happened? Can I able to recreate the same container with same files? I create the container called container1 or pod called pod1. In that pod, I created some files. If I delete the pod, can I able to access that files? That means is stateful or stateless? Stateless. That means it doesn't have the previous state. There is one more example. I create a pod with having some files. Even if I terminate the pod, again pod will recreate with same files. That is what we can call a stateful application. Which one? Stateful means it is gonna store the previous data. Stateless means it is not gonna store any kind of previous data. This volume concept is nothing but stateful and stateless only. That's it. Is the concept clear for all of you know? Now, practically, if I show you one example, you'll be getting the clarity. What I'm doing, first of all, here, the major thing we need to understand is, you know about the PV and PVC. PV and PVC will be the volume. Where you are going to create the volume. In the Docker, we created the volumes locally. Where we created? If you create the volume locally, what happened, Unfortunately, if I delete the cluster, along with the cluster, my data will be deleted. So in this case, if I create the volumes locally, okay, I create the PV and PVC locally. That means inside my cluster only. The biggest disadvantage I'm having, if I delete the cluster, all this data will be lost. All this data will be lost. Now you tell me I have the Minikube. Inside the Minikube, I create the volume. If I delete the Minikube, what will happen? Data will be lost. So that means it is not recommended to create the volumes in locally. Sir, if not the volumes are created on locally, then where we can create the volumes? We can use the cloud. What we can use? Let's take our AWS cloud platform. What we're going to take here, AWS. In AWS, volumes are going to be described as EBS. Correct or not, sir? Let's take, I create the EBS volume in my cloud itself. What I'm going to create? If I create EBS volume on my cloud, even though if my cluster got deleted, will the volume be storing on my cloud or not, sir? That is the primary advantage. In real time also, whenever if you are creating the cluster, if you want to create the volume for the cluster, we don't create volumes locally. Why? Because local volume can create a lot of problems, which is not going to be a good condition. That is the reason in the cloud, we create the EBS volume. In that EBS volume, we are going to put the data of the pods. Now, even though if the pod got deleted or even the cluster got deleted, we have the EBS volume in the cloud. Is it clear for all of you now? All in, is the concept of EBS clear for all of you? Can you please confirm me once? Okay. Fine. So now let's go and implement some practical examples. So you'll be getting some clarity. Okay. So I'll be going with some practical examples now. So it is gonna give the clarity for you. Let me delete them. So here what I'm gonna do is, it is my Minikube server. So I'm gonna give the command kubectl get PV. That means I'm gonna get the list of persistence volume. Do I have any PVs here? Let's go and create pv.yml. So I think all of you know what are the mandatory fields in Kubernetes, right? Tell me what are the mandatory fields? API version, kind, metadata, and spec. So here if you can go and see, I'm gonna create the PV first of all. Guys, PV means our volume. Here in the volume means here we're gonna take the EBS volume here. If you can go and see, instance must be on same availability zone on EBS. That means currently wherever Minikube server is launched in which availability zone? Northern Virginia. But in Northern Virginia, it's a region. But you want to see the availability zone. If you want to see our instance on which availability zone, scroll here. Our instance on which availability zone, US East 1E. That means whatever the volume you are going to create, this volume also going to be on US East 1E. Let me go in, create a duplicate tab. In the duplicate tab, I am going to create the EBS volume. Go and see the volumes here. In the volume section, create one volume manually. I'm gonna create the volume manually with 10 GB. I want only 10 GB, okay? So size instead of 100, I can put here. Availability job, I'm gonna create it as US East 1E. Why? Because my Minikube is on 1E only. You can see it here, right? Minikube is on which availability zone? 1E. So definitely your volume must be on 1E. Click on create the volume. Now, once you create the volume, in this volume only you are going to put the data. This volume. Are you seeing it now? In this volume only we are going to put the data. Copy this volume ID and paste it here. The only thing you want to change here is copy and paste this one. Now you can go and check. Let me explain this PV for you. So guys, in the API version, it is V1 and I'm going to create persistence volume. Metadata. What is the name of the PV here? In the specification, I mentioned the capacity. What is the storage of my EBS volume? In the access mode, you can give read write once. What you can give here? Now in this volume, you can read the data and you can write the data one. That means you can access it frequently. Coming to the volume here, I am using elastic block storage as my volume. It is my volume ID. Whatever the volume we create manually, this volume ID we need to specify here in this manifest file. Coming to the file system type, it is a default file system. It is ext4. Which one? For example, in real time, if you don't know how to write the code, just go to the Google and type PV in Kubernetes. If you type like this, again the same manifest file will come with the example here. If you can go and see, let me scroll down here. In ChatGPT also you can use. It doesn't matter. You can use ChatGPT or anything. Are you seeing the EVS volume here now? It is PVC. It is PV. API version, kind, metadata, storage class name. Okay. So like this, you can get some of the examples. Even though if you use ChatGPT, let me show that one also. ChatGPT. Guys, try to use ChatGPT in your daily activities. Why? Because if you are a DevOps engineer who can use ChatGPT, you will be having a lot of value in the market. I am writing here generate a manifest file. Generate a manifest file with PV in Kubernetes. You can get exact example what we are using here. Are you seeing the exact example here? Okay, this host path we can define later on the pod lifecycle. Okay, that's it. So I'm using the same thing. Again, API version is V1, kind I'm using persistence volume. Name of the volume will be my PV. How much of storage I'm using here? 10. Access mode, I am using read write once. Coming to here, I'm using elastic block storage with the volume ID, so and so ID. Here, file system type will be ext4. Now, if I go here, give the command kubectl create -f pv.yml. Kubectl get PV. Now you can get the persistence volume. You can go and check what is the name of the PV. My PV. What is the volume I'm having? 10 GB. Read write once here. Okay. Reclaim policy retain. That means if no pod is using this one, if I want to use it for my previous person, I can use retain. What is the meaning of retain? To use it back. In IPL, we retain the players, right? What is retaining? To get them back and use for our franchisee only. Here also same policy. Coming to status, is currently is it available or not, sir? Yes. So first point is done. We create the PV for our cluster. After creating the PV, now this volume I want to distribute to the pods. Which component will distribute the volume? Means it is PVC only. PVC main purpose is to take the volume from PV and distribute to the pods. Now in the same way, I'm gonna create one more file called pvc.yml. Which one? So in the pvc.yml, here I'm gonna put the PVC configuration. Again, copy it and paste it here. So API version v1. Now this time I'm creating what here? PVC. What is the name of the PVC? And here coming to the access mode. Here we are going for grid ones. Resource. Resource means how much you are requesting. I am requesting the storage for. Sir, already my PV is having 10 GB. Can it give 10 GB for PVC? Yes. But if instead of 10 GB, if I give here 20 GB, what will happen? Will my PV is having 20 GB here? No. Then Kubernetes will create one more PVC with 20 GB. Already we seen. If our PVC request more volume than PV, it can dynamically create a new PV or it can remain unbound. It can remain what? Unbound. That is the point I mentioned here. You can go and check. You can go. If no suitable PV is found, that means my requirement is 20, but PVC is having only 10. Is it meeting my requirement? No. If no suitable PV is found, Kubernetes will either dynamically create a new PV or PVC will remain unbound. So here I'm just taking 10 GB for my requirement. Now give the command kubectl create -f pvc.yml. What I'm using here, pvc.yml. Hit enter. You can get now kubectl get PV. If you give PV, both PV and PVC come. Let me make it some sort here. Are you getting the PVC here? PVC is having here 10 GB. Again, read write like access only once. Coming to the reclaim, I'm going to delete policy here. Status is completely bound. That means attached. This PV is completely attached for my PVC here. Okay, that's it. Now, if you can go and see, you can attach to this PV and PVC for any of the port. Now here, I'm gonna create the application called stateful application. Which application? What is the meaning of stateful? Storing the previous data is called as stateful. Online is creating PV and PVC. Clear for all of you? Can you please confirm me once? Okay. So now I'm gonna create a deployment here. Deployment.yml. I'm gonna take here. So simply I'll copy the manifest file here. Okay. So here I have the manifest file. I'll be copying this manifest file and I'll show you the remaining process for you to explain. So here I'll open the manifest file for you. So guys, from starting to here, already you know this concept. What is this concept? It is a concept of deployment manifest. All of you know the deployment manifest file. Now from here, I'm going to execute the command. What I'm going to execute? From the bash shell, -c stand for command execution. Okay, bin bash. -c stand for command execution. Which command I am executing here? Sleep 10,000. That means for 10,000 seconds, my container will be on sleep status. Which status? Sleep status. Coming to the volume mount, I'm using my volume called PV. Which one? So I'm using the persistence volume. Coming to the mount point, that means in my container, I'm going to create a folder called TMP persistent. That means whatever the data I put on the TMP persistent, that data will go for my PVC. That means, for example, see, in this diagram, I'm going to have the port. Whatever the data I put on the TMP persistent, TMP persistent. Okay, so I'm going to make it large for you. Whatever I data put on TMP persistent, okay, for small, I'm using TMP PER. That means persistent. Okay, Whatever the data you put on this folder, this same data will be going stored on the cloud. EBS. EBS means my PV only. Guys, here my PV is nothing but EBS, like EBS volume only. This EBS volume I convert to my PV itself. Okay, like that. Next year, coming to the volumes here, already you know we are using the volume called my PV. But to give the volume to the pod, we need to have the PVC. Which PVC I am giving here? My PVC. This is the 5 lines of code you need to understand. Coming to the volume mount. Volume mount means you are adding the data to which location of the pod. I am taking the volume from PV, and in my local pod, I am giving the data to the TMP persistent. Coming to the volumes here, I am taking the PV volume, but I am giving this PV volume from the persistence claim called my PVC. Now, if I go and create the deployment, kubectl create -f deployment.yml, you can get the pod. Kubectl get PO. Are you getting the pod here now? Container creating, wait for it. Wait for some time, it's creating the container. 0/1 means your container is not ready yet, okay? Is your container ready now? Tell me the command, how to execute a command inside the container. Kubectl exec. Kubectl exec -it, name of the container, and you can give --bin bash. So currently we're inside the pod now. Just to give LL. Oh, sorry, here give LS. Are you seeing TMP here? Sir, in the TMP, are you seeing the persistent folder here? It's the folder CD persistent. Now, whatever the data you put on this folder, data will be storing to the EBS volume. Now, I'm going to create some files. Touch file 1.5. I'm creating how many files? 5 files. Wait. Now, give the command cat greater than file1. This file is from pod1 from PV. I'm writing some data, any data. So if you save this one, now come out of the container. Now currently I came out of the container. Your data, Docker not wait. Kubectl get PO. Your data is inside this pod. Inside this pod, you have TMP and persistent. You have the data there. Now what happened? It is the stateful application. What is the meaning of stateful application? That means even though if you lost the pod, you can get the new pod with the same data. So just go and check here whether you are getting the previous data or not. I'm deleting the pod manually. Correct or not, sir? Why? Because I want to get the new pod, and the new pod is going to have my same old data. Let's go and check. So now go and check. Give the command kubectl get PO. Are you getting new pod? Now use the same command kubectl exec. But this time I'm going to execute the command on the new pod. So I'll be taking the new pod here. This is my new pod. Give the new pod. Currently we're inside the new pod. Go to cd/tmp and folder will be persistent. Give ls. Are you seeing 5 files? Cat file1. Are you seeing same data or not, sir? Now again I'll come back and give the command kubectl delete pod, and again I'll be giving the same pod. Sir, if I delete the pod, eventually my new pod will come. Will it get the same old data or not? So if it get the old data, then we can call it as stateful or stateless. Stateful, correct. How it is possible means already in the manifest file we mentioned the volumes. That means whenever if I created the pod, you get the data from this PV only. In this PV, already we put the data or not, sir? What is the PV here? That PV is on EBS volume. Where it is? That means in the EBS already the data got stored. That's it. Let me go and get the pod. Kubectl get PO. You can get the new pod now and try to go to the new pod. It is my new pod. Again, I am going to execute the command. Of course, instead of going to the pod, you can execute commands like this. Give ls/tmp persistent. Wait. It is the old pod name, huh? Wait. Guys, it is the old pod name. That is the reason it's not working. Wait. Like I am trying to execute the command with the old pod name. It is my new pod name. I need to give this pod name. Just to give ls/tmp persistent. Or first of all, just type ls. Are you seeing persistent here? Go for persistent now. Are you seeing the same 5 files now? And give the command file1. But instead of ls, you are going to put which command now? Cat. That means you can go inside the no, you can go inside the pod and you can check. But even though if you don't want to go, you can check from outside also. Is it giving the same content or not, sir? So this is the concept of stateful versus stateless. Whatever the pod till now we created, it is stateless only. But now you created the pod called stateful pod. Which pod? So is the concept of stateful versus stateless clear for all of you know? In real time, definitely you need to use it. See, in real time, for example, your pod is having the data, application data. Unfortunately, when the load is increasing, you need to get the new pod or not? Whenever if you get the new pod, in the new pod, you need to have same old application data or not? How will they get it? In the same way. Without using the P and PVC, you cannot create the pods actually. Is it clear for you know? That's it. Online, is it clear for all of you know? Can you please confirm me once? No, that is different switch now. Okay, fine. So this is the concept of PV and PVC. And in interview, they will ask you a question. For a single PV, how many PVCs we can create? Only one PVC. How many PVCs we can create? And for example, if I want to increase the size of PV, how can I increase? See, my main intention is I want to increase the size of my PV. How you can increase? First of all, you need to go to the EBS volume. In the EBS volume, click on the action. Are you seeing the modifying volume here? In the modifying volume, just go and put 20 GB now. How much? Let's just go and put 25 GB. Once if you modify here, now after what you're gonna do is you can go to the like what we call server here. Give the command kubectl will get PV. What is the size of volume here still? 10 GB. Give the command kubectl describe PV. You can get the still data of 10 GB. Now I want to make it increase. How can I increase? Here I given the volume. Is it modifying now? We have to give the command kubectl apply. But before that, let's wait for some time until it get modified. See, once if you modify the volume, for example, I go for 10 to 20, 25 GB. I can go for 35, 40, 100, 69, 78, 41, anything is fine. I can increase the volume, but I cannot decrease the volume. This is the point you need to understand. Once if I increase the volume, I cannot decrease the volume itself. Again, this concept will come on AWS CBS volume for you. Don't worry it as of now. I'll explain there very clearly. Sorry. CCC, no. Basically, volume modifying means your existing volume will be there. What is the ID here? 79. If you go and see here, is it changing the volume ID? It won't change. Only the amount of storage will increase. But among them, rest of the properties will remain same as it is. It won't increase, it won't decrease. Is it clear for you now? No, if you want to give other volume, create one more PVC. And sorry, one more PV. But in real time, mostly for one PV, we create only one PVC itself. And again, these PVs are for namespace it. For dev namespace, we'll create one PV, one PVC. For testing, one PV, one PVC. Remember, in real time, teams will be organized in the namespaces. For each namespace, CPU, RAM, memory, everything will be separate. That's it. So it's still modifying. Wait for some time. I'll show you how this will be replicated to the PV itself. And one more thing is like this, we can modify the CPU and RAM for servers also. Okay. In the meanwhile, have you seen the Telegram channel today? I posted a requirement for DevOps mentor. If anybody is interested on mentoring, I mean, like it's only for offline student, you can come for mentorship. Okay. We will be taking one interview. Till now, what are the concepts we have done? If you complete on this concept, we'll provide the mentorship opportunity for you. If anyone is interested, please let me know. I think for the previous batch I posted, not for your batch. For your batch, I'm just telling you. Let me check how many of interested. Give me a second, guys. I'll check and like not for your batch. Basically, I posted on some other batch. Okay, fine. Let me refresh the volumes. You can see still the state is modifying state. Like it's completely 99% available. Let's wait for some time. So mentorship timing will be from morning 8 to evening 6 p.m. I mean, like it will be like done on shift wise from morning 8 to evening 5:30, I think so, or 5. Uh, Only on weekends, not from Monday to Saturday. Okay. Is it available now? Currently the state is. So it is completely modified now. Okay. So if I go and check by default, if I give the command kubectl get like describe command, I'll give again for the PV. Still, what is the volume state here? You can see. That means if you increase the volume size, it is not going to replicate here. But if it want to make it replicate, what I can do, VM cube, VM pv.yml. In the pv.yml, what I can say is that instead of 10 GB, what I can put now? Let's go for 20 GB. It's fine. Give the command kubectl apply -f pv.yml. Now you can go and check. Give the command kubectl get or describe PV. Just go for describe PV. In the describe, what is the size now here? That means I can dynamically provision, like I can increase the volume size or not, sir. Sir, if I increase the volume size, still I'll be getting the same application or different application. Let's go and check. I'll give the command, same command, kubectl exec ls. Same command, same command or not, sir? Let me go and delete this one. Kubectl delete pod and name of the pod. Wait. I'll just test it for your verification, whether after changing modifications, like after modification done, will it work same or is it going to work on a different way? Now I remove the pod. Give the command kubectl get PO. I get the new pod. Just try to run the same command for the new pod. Just the only thing I'm going to change is execute the same command, but the name of the pod will, is it executing or not, sir? So this is the concept of PV and PVC. Now in the concept of PV and PVC, is it clear for all of you? Everyone. Online, can you please confirm is the concept of PV and PVC clear for all of you or not? Clear, great. Fine. So next here, I'm going to teach the concept of multi-container pods. Which pods? Sir, what is multi-container pod? Name itself is indicating by default, pods will have how many containers? One. But here I'm going to create the pods with multiple containers. Lot of people might have how to create the multi-container pods. It is very easy. First of all, I will go with the basic example. Then I'm going to show you how to use this multi-container pods in the real-time aspect. There is a concept called container designing pattern, CDP. That means container designing pattern. How it is going to work, I'm going to show you. See, let's go and generate a normal pod manifest. Let me go up here. I just want some like normal pod manifest file. Of course, we can write, but instead of writing, I'm just going for copy paste. Okay. Is a normal pod. Here, it is a normal pod with single container. So I'm going to remove every files here. So here what I'm doing, I'm going to put copy paste here. So for a first container, I can take the image called like Nginx. I think you know Nginx, right? It's a web server. And again, for the second container, hyphen name, you can take the same Nginx or you can take any other. Like I'm going to take CentOS this time. Okay. And name of the container will be container 2. If I go here, oh, wait, I need to give the image name. A small mistake. kubectl create hyphen f raham.yml. Now, if I give the command kubectl get PO, are you getting 0/2? What is the meaning? Now I'm going to use two containers in the pod one. Previously, you get one by one. That means only one container. But here now, /2 indicates number of containers. So one container is running, second container is not running. Why? Because it got crash loop backup. Which one? Crash loop backup is one of the I'll tell you. It is one of the error what you are going to get for the container misconfiguration. If you want to get kubectl get events, guys, this is the very powerful command. It is gonna show you all the mistakes and all the events happen inside your cluster. You can go and check your pod to get failed. Why it got failed here? Container 2 in the pod 1 got failed. Why means we have the warning here. What is the warning? Due to some reason it got failed. Okay, fine. Like we can use same Nginx image also. Wait. Kubectl delete hyphen f raham.yml. VM raham.yml. Let me use the same image name. I think CentOS. The image name got with different tag. I'll take Nginx. Is it running now? So it is a simple way how you can create the multi-container pod. But in real time, we don't create multi-containers in a pod for just playing purpose. There is a specific reason for it. The main reason is why we create the multi-container pod, the main reason is for to work with a single pod in an efficient way. So there is a concept called container design pattern. Which one? So inside the concept, like in the container designing pattern, we have a lot of patterns. First one will be sidecar. Which one? Sidecar means it create the helper container to the main container. Main container will have the application and helper container will do the help for example, see, very smallish, very small, like a example, I'll tell you. I have the pod, sir. Let me delete these diagrams for you. I have the pod. Now in this pod, I have the application. It is my pod. Inside the pod, I have the application here. Now in this application, I'm going to do things like this. I need to check the username and password. Then only I need to serve the application. Now two different activities. First activity will be checking the username and password. Second activity will be the serving the application. But if I do both with the same container, this will have very load and the time of application serving will be very delayed. So instead of giving the entire work for this single pod, what I'll do, I'll create one more container called helper container. Which container? Now what this helper container do? This helper container will check the username and password. See, for example, user name and password will be checking by the helper container. Which container? Now once helper container check the username and password, my main container will serve the application. That means instead of working with a single container, but for the single activity, we can create multiple containers or not, sir? This is the purpose. Here is first one will be my helper container. Which container? And second one will be my, here always main container will give the application, but helper container will help for the main container. So is the concept of sidecar clear for all of you? Online, can you please confirm with the sidecar clear for all of you or not? Clear. Fine. So if you want to do it practical way, so basically it is not required, but I'll just give the glimpse of practical way. Just go to the chat GPT and you can get a lot of examples here, but I'll tell the best example for you. Guys, the reason why I'm extensively using chat GPT for our classes is this you need to learn a lot. I'm telling you, previously, few years ago, there is no chat GPT. But today, a lot of people are using chat GPT in daily works. If you know chat GPT, how to use your chat GPT in your work, you will be having lot of advantages. That is the reason I am showing you. Even though without showing the chat GPT, I can go to the official documentation. I can get the same example. But instead of following the official documentation approach, I'm using this example for you. So now generate an example for sidecar pattern in Kubernetes with example. That means I am asking the theory as well as I am asking the both example also. See, let's say you have a main container that serves the application and you want to include sidecar that can handle the logging of the application. Same example said or not, sir? Logging information by the helper container, main application from the main container itself. Now, if you go and see the example, you can copy this example and you can paste it here. Okay. So VM sidecar.yml. So here you can change some properties. First one will be main container. So your image name, basically we need to give the image name here. What we need to give? Image name. So we have a lot of images here. I can give any image application, but here I'm not giving any image. Okay. But if you wish to give, you can give any of the image. So our image name is Ani Kaluri 007 or like 00 only, right? Paytm movies latest. Container port number will be 80 only. And coming to the sidecar, here for sidecar, you can take any of the image. It doesn't matter, guys. You can take whatever image. Basically, we need to create this custom image, but here, as of now, I'm taking Nginx. And whatever the logging information, that means username and password I'm entering, this will be storing on the logs. This will be storing on the, where it is going to store on where log web app. And coming to the volume, in my local, the name of the volume will be logs volume. But of course, I don't have this volume in my local, but I'm just showing you. The reason why we are not creating the volumes in local means because in local, if you create the volume, it is going to delete with the cluster. That is the reason I ask you to go and work with the PV and PVC from the EBS volume. Kubecut will create -f sidecar environment. Kubecut will get PO. Now you will be getting the pod here. It will take some time, and after that you can create. Are you seeing 2x2 pods are running? Now first pod will take the information, and second pod is going to show the information on the logs. What is the log path? Var log web apps, like that. So is the concept of sidecar clear for all of you? Know? Online, can you please confirm is the sidecar clear for all of you or not? Clear, fine. Second one will be adapter designing pattern. Which one? Adapter designing pattern means standardize the output pattern of the main container. For example, see, in the main container, you get the data, but data will be not on comfortable pattern. For example, if data is on different pattern, it is very difficult for to read. If you go for the concept called adapter designing pattern, this adapter designing pattern will collect the logs from the container, and it is going to make the output on the standard format. Which format? Like JSON, ML, or like structured format actually. So if you want to design those kind of containers, you can go for the concept called adaptive designing pattern. And third one will be ambassador. Which one? Use it to connect the containers with the outside of the wall. For example, see, you have the container. In the container, you have the data. But in the container, you are having the application. But this container, you don't want to export to outside of the world. So in that case, application I can give to the helper container, and this helper container will go and expose the application to the outside of the world. That means instead of exposing the main container, I want to expose some dummy container to the world. In that case, I can use the concept called ambassador. Which one? The best example is Chandramukhi. Chandramukhi. No, Chandramukhi, right? In Chandramukhi, instead of burning the live Rajnikant, they burned the statue of the Rajnikant, right? That means here are the same pattern. Instead of exposing the main container which is having application, I'm exposing the dummy application. Sorry, dummy container. Which one? From the dummy container, my application will be exposed. So same concept is used in the Chandramukhi. Which one? Chandramukhi. That means Chandramukhi team copied the pattern. Tell me, is it copied or not? No, sir. Chandramukhi came on 2005, but it came on 2014. Is almost 10 years of difference, right? Like that. So to design these kind of patterns, we are going to use something called as ambassador. Again, sidecar. Sidecar is nothing but it is going to help for the main container. Ambassador, it is going to stand at the output of the containers. I mean, like whatever the data collected by containers, it is going to give the standard output. Third one will be ambassador pattern. That means instead of exposing the main application, that means main container to outside of the world, we are going to expose the dummy container. That dummy container will take the application from main container and give to the outside. Okay. Last one will be init container. Which one? Init container means it will work only one time. It will work only. Let's take inside your container. You want to deploy the application. To deploy the application, you need to have the code. What you need to have? So first container will give the code to the second container. After giving the code to the second container, now I don't have any work with my container one. I can delete this one. This is what we can call as use and throw method. Which method? That means if my work is done, I don't want my first container. You can go. You can leave and you can take the rest. Okay. Here in this kind of methodologies, we are going to put the source code on container one. Once container one give the source code to the container two, we don't need the source code for second time. You want only for first time now. So what you can do, you can cut off this container one and you can use the source code from the container two itself. So these kind of patterns are what we can call as init containers. Is it clear for all of you? So this will be called as the container designing patterns. Which one? That's it. So sidecar, adapter, ambassador, and init container. Which one? That's it. Oh, yes, we can use. So init container and sidecar will be the most used one, if you ask me. And again, basically this kind of things we are going to take the developers help by, because they will guide us how the pod need to be execute with the application. There is a certification called CKID, Certified Kubernetes Administrator Developer. So these kind of people will design these patterns, but as an administrator, definitely need to have some understanding about this one. Okay. So again, multi-container pods are nothing but maintaining more than one container. This also we can call as container designing pattern. Remember, multi-container pods or container designing pattern, both will be same only. Don't confuse here. So in today's session, which topic we have seen? We have seen stateful versus stateless, as well as container designing pattern. See, PV and PVC means stateful versus stateless only. So now, any doubts or any queries in today's session for you? No queries, huh? Online from you guys? Is the session clear for all of you? Can you please confirm me once? Clear. Great. So now tell me, is Kubernetes really difficult to understand or easy to understand? Already I said, codes are greater than concepts, or concepts are greater than codes. Concept is greater than. From the day one, I am telling this one concept. If you understand the concept, everything will be fine. Otherwise, think. Okay. Yeah. And in tomorrow's session, I'm going to start the monitoring. Which one? Of course, Kubernetes is not done yet, guys. Okay. There is a concept called Helm charts, Argo CD, Ingress. These concepts are pending, but I'll start monitoring tomorrow. In the same monitoring, I'm going to show with the help of the Helm itself. Which one? Helm itself. And if I go to the syllabus copy here, let me show you the syllabus copy. Wait. So it is your syllabus copy. That means what exactly I'm going to teach you, you can get this from here. Okay. So here, let me go ahead and tell you like how many classes we still have, and one by one. Don't worry, I'm going to take some additional class also. It's not about the syllabus. I'll complete only this much of syllabus. I given only this much. It's not like that. Okay. I just want to give the entire clarity for you. So currently where we are, on here, resource quotas, multi-container pods done. So next I'm going to tell you how to update the OS in a theoretical way and what is the cordon and draining. So Prometheus, Grafana, and Node Exporter. Later I can go for Helm, which is the Kubernetes concept. Argo CD is also going to be the Kubernetes concept. Now, once all of this done, then again I'm going for the AWS concepts. So Elastic Load Balancer, EBS volume. So everything will comes into the picture now. Okay, then finally we are going for the Terraform itself. Clear? Fine. So now, if you are having any queries over any topics, we can discuss. We still have a lot of time. You can go ahead and you can ask me the doubts and queries. Ankit, you raised your hand. Wait. You can speak now, Ankit.
Hi, sir. Good evening.
Ankit, wait, I'm not able to hear you.
Can you hear me
Please
now,
speak
sir?
now, Ankit.
Hello. Yes, sir. I'm here. Am I audible?
Yes, you are audible.
Hi, sir. Good evening, sir.
Good evening, Ankit. Tell me.
Missing the offline classes. So,
We are also missing you, Ankit.
So actually, I have a question regarding
Um,
real-time projects actually. So I have heard from so many like DevOps engineers. So few of
mm,
them are working, and so whichever of them are asking as of now, they are talking about projects moving like to cloud. So they are
mm.
working mostly on application moving to cloud. So how does like DevOps, what is the role of DevOps engineer in that? And like what are the technologies the is used like we are studying right now?
Basically, cloud migration will be different, Ankit. But if you ask me, like migration, there will be hell lot of migration. But among them, the first one will be lift and shifting method. Lift and shift. Second one will be lift, modify, and shift. There are a lot of methodologies we are going to have for the what we call this
Cloud
one, cloud
migration.
migration. Let me go and show you. Just now you asked me, like I'll show it lively. What are the two
Sure, sir.
methods I shown you? You are going to get it now. Like wait,
Sure,
cloud
sir.
migration techniques. Lift and shift, lift, modify and shift. This will come for the top two. You can see here. Are you seeing lift and shift now first method?
Yes, sir.
This is the first method actual. I'll explain this one. Basically, it's not a part of your syllabus, but if you are interested to learn, I'm going to explain. Second one will be lift, shift, and there is something. Wait, where it is? Arey man.
Till awards.
Wait. There is one more method. Basically, it not come here. There is one more called lift, shift, and remodify something like whatever it can be. Okay. So these methodologies we are going to use. But if you want me to explain, I'll explain them. Don't worry about it. Okay.
So like we are studying Terraform
Yep.
like technology. So here like those technology like we won't be using those like how does what do a DevOps engineer role in these things?
In this thing, definitely
Yes.
DevOps need to take a lot of place. See why? Because lift and shift mechanism is nothing. But let me explain. Like if I read the small sentence from the previous chart, you'll be getting. Wait.
Sure, sir.
Uh, what we call this one? Cloud migration.
Cloud migration.
Okay. So now you can see, first of all, I'll go for lift and shift. It is telling that in rehosting, that means lift and shift can also be called as rehosting. In rehosting,
Mhm.
also called as lift and shift method, application are moving from on-prem to the cloud
Cloud.
without redesigning and rearchitecture. That means, see, for example, in the on-prem, you have three-tier infrastructure. Same infra you
Mm.
are going to create on cloud also. In that case, what you are going to use? You are going to use Terraform. As well as
Okay.
whatever the application that you are migrating from on-prem to your current servers. For example, let's take you are migrating the Java application.
Mhm.
Definitely in the server, you need to install Java. How can you install by using Ansible? Correct or not?
Correct, sir.
Definitely in the cloud migration part, without DevOps, nothing is going to happen there. So we need to play a lot of role in that. Second one, if you can go and see the lift, modify, and shift. Modify is nothing but tinkering. I think you know tinkering,
Think.
right?
Yes, sir.
Tinkering. It's a general term. Tinkering means if something is not working properly, if you fix, that is called as tinkering. Okay, that is lift, modify, and shift method. So I'm going to explain this technique also, even though it's not a part of your syllabus, but I'll definitely give an overview if you want.
Yeah, sure, sir. That would be helpful because I have like as like I when I came back here, like I met so many of my friends who are in
Hmm.
industry. So
Hmm.
I spoke to them. So they told me, yeah, you're like very updated.
Yep.
And like I asked what project you guys are working on. So like three of my friends are like working here, like with experience.
After
So I.
after done with Terraform, Ankit, you can tell
Mhm.
whatever the project you done. Why? Because without Terraform, we will not be including any project here. Okay. So if I teach
Correct,
you
sir.
Terraform, then you'll be getting the complete idea about the architecture as well as like infrastructure. I'm telling you one
Okay.
thing. If you
Mhm.
understand Terraform very well, projects are simple. Okay.
Okay, sir.
Yep.
Okay, okay, sir. So in Terraform, all the like concepts will be utilized, like Docker and all. Like, is it?
That you will come to know what I am going to teach. Okay. Don't rush it
Okay,
as of
sure.
now. Okay.
Sure, sir. Sure. Thank
I
you,
can
sir. Thank you.
understand your enthusiasm, but you need to hold for some more days, Ankit.
Yeah, sure, sir. Sure, sure.
Yep.
Thank you, sir. Thank you.
Thank you. Mm, there is no limit for Kubernetes, first of all. Can I tell you one thing? To learn the Kubernetes, Complete Kubernetes. You know how much time it will take? It will take more than 1 year. Trust me, to learn the complete Kubernetes, complete end to end, it will take how much? Sir, then how come you are completing the course within 2.5 months? That's what your next question, I know. I'll ask you a small question. Dadapir, you are comfortable at which language? हिंदी. हिंदी में सब बात है आपको? No, no, you know complete Hindi end to end. Complete end to end. Ah, that's what correct. Same here also. If you ask me, all of you know English, but tell me, is anybody can tell, sir, I know 100% of English? No. If you know the complete English, you'll be in Oxford University, right? You'll be a professor at Oxford. You'll get the PhD also. Here also, the only thing you need to understand is we are not here to master and to learn any of the complete tool. How much of real-time knowledge we want, that much of knowledge we are going to learn here. Okay. Don't think you need to get the complete Kubernetes or you need to get the complete Docker to work. Even though the people is working on real time for 10 years and 15 years, they will not don't know the complete Kubernetes and Docker. If they know complete Kubernetes and Docker, everybody will become trainer, right? How much of they want? That much only required. And even if you ask me, sir, how much of DevOps, I can't give the guarantee. Not only me. If you go to any institute, I'm betting you this one. Nobody will tell we know complete DevOps, we know complete Java. Nobody will tell you. Why? Because for technicality, there is no end. This is the practical world I'm telling. And I'll speak the truths only. If somebody is gonna tell you, I know complete AWS, I know complete DevOps, don't trust them. It's not possible practically. Why? Because for Kubernetes, we have a lot of extensions. Nobody will speak about the extension. And for Terraform, there is something called as OpenTofu, which recently came into the market. There is something called as a HashiCorp cloud platform, which 70% of the people don't know about HCP. But that doesn't mean like they are not good at Terraform. It depends upon the methodology what you're gonna use. Okay. Never try to learn anything in a full depth. Why? Because there is no end for technicality. I'm telling you this one. Yes, master of one jock, non-jackal of all. Correct. But I am telling you, how much you want for 3 to 4 years of experience that you can get from here. I'm betting you by the end of the course, if you learn completely, just to go and apply for 3 years of experience. I'm telling this for everyone, even though if you're a fresher, prepare your resume like for 3 years of experience and go and attend for that like interview. I'm betting you definitely you can crack it. Without any doubt, I'm telling you this one by this much of confident. That's what I'm saying. After the course, you need to practice very well. After practicing, I'm telling you, if you go to any interview for 3 years of experience, you can crack it. I can bet you. Okay. But I'll tell you one more thing also. Before going for any interview, just to see the job description. JD is very important. For example, see, in the class, what I taught you, Jenkins I taught. But if they require a bamboo, you don't know bamboo, what will happen? Then you can go for interview, they'll ask question on bamboo. Then you can come back, sir. You said that 3 years of experience, we can crack interview. But what happened there? So the main thing is all DevOps engineers job will not be same. Why? Because a different organization will have different projects and for different projects tool will vary. But again, the end of the day work will be same only. If you use bamboo, if I use Jenkins or if some other use AWS CodePipeline, at the end of the day, all of the things are going to do the deployment only. But the tool will change. You can ask me, sir, all people can use the same tool now, but why these different people are using different tools? The main reason for it is it depends upon the client requirement. Sometimes client will tell us to use these kind of tools only extensively. They will guide us. You definitely need to use these kind of tools only. So due to that reason, lot of organization will have the different tools. And some of the organization will have the inbuilt tools also. That means they will build their own tool actually like that. So for Kubernetes, can we use Linux? Basically, Kubernetes built on top of Linux only. If not Linux, then what will use? Sirisha definitely need to use Linux only, Sirisha. And again, you can ask, sir, it's platform independent. Now, is it not going to work on Windows? Means, of course, it work on Windows only. But Linux is more compatible with the Docker and Kubernetes. But there is no script for Minikube, sir. Minikube script is there na in all setups. Are you trying to install on Windows Machine, Sirisha? Oh, for Amazon Linux. Wait, for Amazon Linux, correct Linux only. Which Linux? Ubuntu Linux, Amazon Linux. Like I need to get the clarity on. And Tapas, OpenShift is same. Yes, there is something called as Red Hat OpenShift. Red Hat OpenShift is also alternative for the Kubernetes. And there is one more thing called as Apache Mesos. Apache Mesos is also going to be alternative for Kubernetes itself. There are a lot of things. For Amazon Linux, we have the script actually. Wait, but that is not working. Why? Because the latest version got changed for Amazon Linux. Let me show you. Are you seeing mini al.sh? It is a mini queue for Amazon Linux. Previously, this script got worked, but I think so it's not working in the recent days, but you can go ahead and check. Last time when I tried, it's not worked. From then, I never used this kind of script. If you want, you can check, Sirisha. Yep. So, still any queries from you, offline or online? Yes, we have a lot of script. Helm is there. Even Argo City will be not now in upcoming days. I'll show you Argo City. So, guys, still any queries or question from your side? Process. Bring your resume, give the interview, join as a mentor. That's it. Huh? They'll pay. 8,000 will be the starting one. But if you prove yourself, one of the mentor got here 16,000, I think, so highest. Highest. It depends upon your performance actually. Sir, may I know practicing with MobXtreme is good. Definitely, Yogesh, in my real time also I use it MobXtreme only. Why? Because in MobXtreme you have multi-execution mode. But whereas the other terminals will never have any kind of multi-execution mode. I'll suggest to practice on MobXtreme only. How much time is required to complete all the content? Like, are you asking about DevOps, Pallavi? And Tapas, thank you, sir, for giving a lot of info. Stay updates in the DevOps. Pleasure. Pleasure, Tapas. Fine. Sir, in real-time projects, work in MobXtreme. Yes, I said no. So definitely I work on MobXtreme only and I use you to use MobXtreme only. Okay. Why? Because I'm telling you, here I'm not taking the classes for you. Here I'm sharing my real-time experience with you. Whatever I faced, whatever the market is exploring now, whatever the market is going for the undertrends, everything I'm giving for you. If I do something, then only I'll tell for you. If I don't do something, I'll never tell that for you. Okay. Definitely there will be a lot of security issues. That is the reason we have the DevSecOps team actually. For security, whenever I get the concept of VPC, I'll start the security from VPC concept. And there is one more recent trend called WAF, like that is called as web application firewall. There is some attack called BDOG attack. Have you ever heard about like a BDOG attack? BDOG attack means what happened, if I write the Python script, that Python script will go and hit the server for 10,000 times. So eventually, if I hit the server for that many times, what will happen? Server will be crashed intentionally, correct or not, sir? That is the reason what we are going to use web application firewall. That is gonna see the duplicate attacks, what is gonna happen for our web application. Again, if I get a time, I'll take one session for it and I'll explain how it is gonna happen for you. And of course, we have pen testing there, penetration testing. Okay, so we have a profile called DevSecOps as well as performance testing. In the performance testing, there is a like model called pen testing. That is called as like what we call. Let me explain the full form. Basically, I forgot this one. Right. penetration testing is the full form and pen is a shortcut. Okay. So to make it basically for the testing, we have two things, functional and non-functional. Okay. So whenever I get a time now, I'll explain how the testing models will happen in the real-time organization also. Which tester will do what kind of work? What is manual testing? What is automation? What is functional? What is non-functional? Whenever I get it, definitely I'm going to take this one for you. But because my major intention is to give the realistic way for you. Okay. Sorry. It's not your internship now. You cannot go into it. Okay. Okay, then chalo. So let's meet on tomorrow's session with some new topic. Have a great day. Bye all. Thank you. Thank you everyone. So, okay.